In this video, we'll discuss problems and conceptual exercises of chapter 3 from the book James Walker. So here in this question we are given that vector A points along the positive x direction and it has a magnitude of 75 meter. So let's draw this vector. This is the vector A and the magnitude of vector A is 75 meter. Now the vector C, which is the sum of vector A plus vector B, points along the positive y direction and has a magnitude of 95 meters. So vector C would be like this. This is the C vector, which is the summation of A plus B vector. Now we have to sketch A, B and C vector. A and C we have already drawn. Now you have to pause the video and think what would be the direction of B vector and its magnitude. I hope you tried. Now let's sketch the B vector. So B vector would be like this. This would be the B vector. Because we know that the summation of A plus B vector, which is C vector, is obtained by joining the tail of A vector, the first vector, and to the head of B vector. So that is why this should be the direction for B vector, and the length of this arrow would be its magnitude. Okay. So this is the solution for the A part. Now next we're going to solve the B part, where we have to estimate the magnitude and the direction of vector B. Now direction we always measure from the positive x direction and in the anti-clockwise direction. So this would be theta B. Now clearly it is visible that this angle theta B will be greater than 90 degrees and near about you will get this value to be 130 degree. I'm just estimating it. Okay, now the magnitude for the B vector. Now clearly it is visible that the B vector, the length of this B vector is greater than the this arrow for the C vector, and the magnitude for C vector is 95 meter. So it should be greater than 95 meter, and it would be near about, you would say, 120 meters, something approximately. This value would be the correct. Okay, this is just the estimation. Now in the C part we have to verify our estimation in the part B. Okay, now we'll get the exact values. Okay, from this equation we can write that the B vector will be C vector minus vector A, like this. Now what would be the x component for vector B? Cx minus Ax. Similarly the y component would be Cy minus Ay, like this. Okay, now the C vector points along the positive y direction. It has no component along the x direction, so this will be 0, and then minus Ax. Now x, this A vector is along the positive x, so this would be our Ax. So this is 75 meter. So this is the x component for the B vector. Now the y component, Cy is itself the C, which is 95 meter. So this is 95 minus Ay would be 0 because it has no component in the y direction. 0, so this would be 95 meter. Now it's pretty simple. The magnitude would be under root Bx and its squared plus By and its squared. So this would be under root minus 75 square plus 95 and its squared. So this value would be near about 121 meter, which is approximate to this that we estimated, 120 meters. Okay, so this is the exact value. Now next, theta B will be tangent inverse the y component over the x component. Y component is 95 meter, x component is minus 75 meter. So this value comes out to be as minus 52 degrees. Now why this is minus 52? actually this angle is 52 degrees, and since we have measured in the clockwise direction, that is why this value comes out to be as this minus 52 degrees. But actually we always measure it in the anti-clockwise direction, this angle. So what would be the exact value, the correct value basically? Minus 52 degrees plus 180 degree. So this should be 128 degrees. So this would be the answer for the C part. So here in this question we are given a vector A that points along the negative y direction and has a magnitude of 5 units. So this is our positive y direction, this is the positive x direction. So the vector would be in the negative y direction, so this would be the vector and its magnitude is 5 units. So A, we have 5 units. Now next we have a vector B that has twice of the magnitude of vector A and points along the positive x direction. So the vector would look something like that. This would be the B vector. The length of this arrow is just twice of this arrow because the vector B has twice the magnitude of the vector A. Okay, now there are 3 questions that we need to solve. In the first part, we have to find the direction and the magnitude of the vector sum vector A plus vector B. Now we already know how to add 2 vectors. So vector, let this be vector C. We can name it vector C. So vector C would look something like that. This would be vector C. And if you have any confusion that how we added this vector, you can see my previous videos where I have discussed how to add 2 different vectors, and for that you can click on the bell icon. Okay, now we have to find its direction and magnitude. Okay, now the magnitude, the x component would be ax plus bx. Similarly the y component would be ay plus by. So Cx would be equals to, now since the vector A points along the negative y direction, it have no components along the x direction. This would be 0. So Bx, now Bx is itself B because it points along the positive x, and its magnitude we have double of this, that is 10 units. So this would be 10. Similarly we'll get this value Cy to be 5 because By is 0 and Ay is nothing but A, which is 5. So it's simple now. The magnitude would be under root Cx and its squared plus Cy and its squared. So we'll get this value to be under root 10 square plus 5 square. And actually this should be negative 5 because it points along the negative y direction. But when you square it, you'll get a positive number. And on solving this, we'll get this value to be nearly 11 units. So this would be the magnitude. Now what about its direction theta? It would be tangent inverse the y component over the x component. So y component we have, this should be, I've just put it here, this should be negative here because it points along the negative y direction. Okay, so minus 5 over x component we have 10. So we'll get this value to be minus 27 degrees. Now why it is minus 27 degrees? Because you are measuring angle in the clockwise direction from the positive x. So actually this angle is 27, and we generally give or we generally measure our angle in the anti-clockwise direction from the positive x. So this theta would be we could say 333 degree. We have just added 360 to it and we'll get this value 330. This angle is this 333 degrees. So this is the magnitude and this is the direction. Now next we're going to solve the B part. Now next we can solve the B part where we have to find the direction and the magnitude of vector A minus vector B. Now actually we can rewrite this vector as vector A plus negative of vector B. We can write this way, and we already know how to add 2 vectors. Now let me show you this vector addition graphically also. so you have better understanding. This is our vector A, and negative of vector B would be along this direction, just opposite to vector B, but its direction would be opposite. So this is negative of vector B. So its vector sum would be in this direction. This should be the vector sum. Let this be the C vector. Now we can represent it here also. This is our vector. This is A vector minus vector B. Now we have shown graphically. Now we're going to find its magnitude and direction. Now in this part, let's try to solve this B part by using unit vectors that we discussed earlier. So vector A, we can write this as this is along the negative y direction and have magnitude 5. So this would be minus 5 y cap. And vector B, this would be 10 x cap. Now vector A minus vector B. So this would be A vector, we have minus 5 y cap and minus 10 x cap. Now its magnitude A minus B vector, this would be equals to under root the x component square plus the y component square. X component we have minus 10 and it's squared plus this is minus 5 and it's squared, so we'll get this value to be 11 units. Now theta, so theta would be tangent inverse the y component over the x component. So y component we have minus 5, x component we have minus 10, so we'll get this value to be 27 degrees. Now you should know what this 27 degrees is. This angle is 27 degrees, and we are able to give this answer just because we have drawn this vector graphically. It becomes very easy when we graph the vector before solving the equation. So actually this angle is 27 degrees, but we measure our angle from the positive x direction. So this total angle would be, we have to add just 180 to it. So we'll get this value to be 207 degrees. So this would be the theta and this would be the magnitude. Now next we can solve the C part, where we have to find the magnitude and direction of the vector B minus vector A. Okay, again we can rewrite this vector as vector B plus negative of vector A, and we're going to follow the same procedure that we did in the B part to solve this equation, this C part. Now you have to pause the video and you have to represent this vector on this graph on your own. Now I hope you tried, so let me represent and you can match that whether you got the correct answer or not. So this vector will represent vector B minus vector A. Now we can follow the same procedure to find its magnitude. So this is B vector minus A vector. So B vector we have 10x cap minus, now A vector we have minus y cap, so minus A vector would be plus 5y cap. Now its magnitude would be B minus A vector, so this would be under root the x component plus the y component. So x component we have 10 and it's squared plus 5 and it's squared, so we'll get this value to be 11 units. Now next theta, so theta would be tangent inverse the y component over the x component. So y is 5, x is 10, so that would be equals to 27 degrees. Now this time the 27 degrees is this angle, this is 27 degrees from the positive x. So this would be the direction and this would be the magnitude.